Welcome to Battery Industry 3.0, How to Compete with China. So today I have with me two exciting panelists. Really excited to have them on with me. I have Chris Burns and Cameron Dales. So why don't you each give a quick introduction to yourselves and what each of your companies does? Let's start off with Chris.
Great. Thanks, Tal, for having me, and thanks everybody for coming out. I've been in the battery material space for about 15 years, did my PhD in physics with Dr. Jeff Don, and started NOVONIX back in 2013 to focus on how we could accelerate the pace of research and development and innovation in the sector. I then spent a couple of years working for Tesla, and after that, we pivoted NOVONIX and started focusing on producing materials with cleaner process technology for this impending localization in the market. So in 2017, our biggest area of focus became synthetic graphite. So we have operations in Chattanooga, Tennessee. We'll begin production from our Riverside facility next year with an offtake with Panasonic Energy. We won a $100 million grant under the MESC program, $103 million tax credit allocation. But this is a challenging market to break into, and China's been working on it a long time, and that's why this is such an interesting topic. But there's such a great opportunity for innovation to be able to position companies here in North America and outside of Asia to be major participants in the sector.
Thanks for joining us, Chris and Cam.
Sure. Yeah. Thanks for the opportunity, Tal. Really appreciate it. And Chris, it's great to be on a panel with you. You guys are doing some amazing things. My name is Cam Dales. I am one of the co-founders of Peak Energy. I've been in Silicon Valley my whole career, did a couple of startups, one in material science and one in batteries called NOVONIX. We were fortunate enough to bring both companies public. I was at my largest investor as a VC, a company called Eclipse Ventures, and that's where I met my co-founders, and we ultimately decided to launch Peak Energy. So Peak is, I think, a good example of a battery 3.0 type of a company trying to learn from the generations that came before us and leverage the capabilities that have been built as an industry to launch a company that is focused on sodium-ion batteries, which are scaling rapidly in Asia. And we think that the time is right to bring that technology to the US market, starting with grid storage. And there's a huge opportunity, probably $1 trillion of investment going to go into the ground on large-scale grid batteries, basically backing up what is literally the lowest cost of energy today, which is solar. And we've built a team. We're about 60 people. Most of us have operated at scale in our previous careers in the battery space, and we're trying to leverage that experience and capability to build a company at a timescale that matters, both for our investors, of course, but also for the mission that we're going after in clean energy.
Awesome. Thank you both for joining us. And yeah, I think that point you hit on basically any battery that doesn't get used. One of the big lessons I think for 3.0 here is that we've hit economies of scale driven by those price points China's helped point us to. And any battery that's not going to get used in an EV will get used on the grid or other applications. All of those applications pencil out today. What I'm going to walk through at first here is just a quick rundown of the three generations of the battery industry as we see it. We started off with 1.0 in the early days. This was roughly the mid 90s to the mid 2010s. A lot of low volume, high value applications. It started off with the camcorders, then laptops, power tools, drones, and then very low volume, high value EVs with Model S. And then there was a whole range of companies primarily in Asia that were able to take this technology and slowly scale up, increase energy densities, start to learn how to manufacture, start to learn how to produce these things. When we first started Voltaiq, people could make money at $1,000 per kilowatt hour, and there was DOE prizes around getting to $100 per kilowatt hour. We've passed that by far at this point. There was also a lot of early challenges around safety issues with the early batteries, but largely by combination of QC and protection ICs and BMS technology, we improved the technology to a point we could scale it out. And really, we started this company at the tail end of this 1.0 age, really realizing that in order to hit scale and improve quality where we needed to, we're going to need to have the relevant data and information to enable the safety and reliability of these products. We then moved on to this 2.0 area. Everyone was really excited about Tesla getting the Model 3 and the Model Y. Their share price was going through the roof. Everyone jumped into the mass market here. Everyone wanted to build a gigafactory. Everyone wanted to be an EV company. Everyone wanted to get in the game. So we had a whole range of joint ventures. How hard can it be? We've been manufacturing for decades. They're just a scrappy startup. We had a whole range of these gigafactory startups emerge and essentially try to boil the ocean. We're going to do everything from incoming material and mining all the way through manufacturing the batteries, building systems, recycling, you name it. And then, yeah, the cell suppliers who grew up in Asia try to basically copy and paste, and we'll just take that factory we had in, Japan, Korea, or China and build it in Europe or the US and copy paste. And throughout this next phase, we saw a tremendous amount of investment go in, but we also saw a range of production delays, safety incidents, and recalls, and really didn't see the promise that we were expecting from Battery 2.0. Where did this all go wrong after billions of dollars invested and really not much to show from it from the bottom line for many of these companies? For the OEM side, especially in automotive, electrochemistry is not what your mechanical and electrical engineers do. I remember talking to the lead battery engineer at one of the big three, and she was like, the rest of our team just thinks the battery is a source and sink of energy. They don't understand that how you have to integrate the system around it. So that was one of the big challenges here is batteries, because of their complexity, this living, breathing electrochemical organism is not just a mechanical component. So that was hard for the OEMs to understand. The gigafactories, we had a range of them both in the US and Europe who really thought they could do a whole range of different things, and they're all good in practice. But the reality is, if you want to make money, you have to be able to make battery cells and you have to be able to produce them at scale if you want to be profitable. And then a lot of the factories that the 1.0 leaders in battery manufacturing thought they were going to be able to easily copy and paste over into the US and Europe ended up taking 3-4 years to scale up and get to profitability. And with that, it really slowed some of their expansion. A lot of them had safety issues and recalls. A lot of this was really driven. This was a relatively small industry done essentially on a semi, artisanal fashion where, the engineers from Japan who knew exactly what the slurry needed to look like and what the sheen on it was, that wasn't well documented. It wasn't really a data-driven process. And so when you tried to transfer that over to somewhere in the middle of the United States, those technicians had no idea what that's supposed to look like. They really needed documented, they needed data-driven processes. And everyone started to see the value and need for analytics, but a lot of people tried to build their own. This is again trying to boil the ocean. We could do everything. We could be analytics companies too. It was the barrier to entry to write software is easier, but in practice, it was actually much harder than they thought. In the meantime, China was chugging along. They had a master plan they've been operating with, and they've been subsidizing the entire supply chain from signing mining contracts and putting in place a lot of the resources to build a large domestic workforce, as well as the entire supply chain needed to make and produce not just batteries, but also EVs for their domestic market, and are now able to compete with the broader market. With that has also come a little bit of an oversupply right now in that domestic market, and those glut of cells, especially from the tier 2 and tier 3 players that now are struggling to sell to the domestic market, are available for use externally. The good thing here is we've hit these amazing price points of around $50 per kilowatt hour or lower. But we're still seeing safety incidents. We're hearing about recalls from a number of our customers that are coming down the pipe as well. And so this is, if you don't qualify these cells, it could lead to a lot of problems. And so the question here is, can they sell below materials price for much longer? With the economies of scale, don't count them out on continuing this trend towards low prices. And overall, it's going to be a positive for the market. It's time to figure it out. If you want to compete, the name of the game now is really achieving scale and quality and getting there as quickly as you can. There's a couple key things that we see going forward in the playbook we see for especially automotive OEMs and battery manufacturers is you're going to have to move faster, you're going to have to learn faster, and you're going to need to digitize, you're going to need speed, and you're going to need to focus on your core competencies, and you're going to need to ensure that quality is up there if you want to achieve success. For battery companies, it's narrow your focus, make cells, make materials, bring in experts for things that your team doesn't have in-house. You can't afford to build that expertise everywhere. And you're just going to have to learn faster and just iterate and get those products out to market quickly and hit economies of scale. On the OEM side, it's if you want to have those low price points for EVs and products, you're going to have to utilize China in some capacity. And the key there is you're going to have to really use digital tools to really ensure that you are picking the best batteries and you get reliability in those systems in the field. There's companies like Apple and Tesla who've for 20 plus years now been really arduously, studying their supply chains and understanding what are the best cells and understanding the traceability of those. So even when they do have a safety incident, they are able to learn from it and remediate it. So able to select and do targeted recalls versus fleet-wide recalls. We announced this at the battery show a couple weeks ago, partnership between NOVONIX and Voltaiq, really pairing our battery analytics expertise with a lot of the hardware and materials and R&D services that NOVONIX is bringing to market as well, and really bring those to help accelerate not only NOVONIX's solutions, but also our mutual customers who are doing a lot of services with the equipment NOVONIX provides, as well as R&D services. Now, if you go and utilize NOVONIX R&D services, customers will be able to view and analyze data in real time through Voltaiq. They'll be able to access all the materials and design metadata for the cells and allow you to really bridge with your internal development and have a seamless environment here where you could really learn from those development studies as you look to scale up production. And we're also having plug and play integration directly with NOVONIX ultra high precision coulometry equipment as well. And if you're interested, feel free to sign up for a demonstration. And so with that, I think we're going to open it up to the Q&A here. I'm going to start off with a question up front. So one of the interesting things I think with Cam is he took a little foray between his last couple startups into the venture capital world. And you said there was a similar thesis around the 1.0, 2.0, 3.0 type of industries. And it'd be interesting to hear from you on that topic.
Sure, Tal. Yeah, it's a super interesting concept. And I can't take credit for this. One of my partners at Eclipse, Charlie Mwangi, is a big kind of proponent of this approach. And he uses it as a framework to think about investments. And the concept basically is that there are different generations of companies and different generations of technologies in a specific technology. And you outlined it quite well, I think, in terms of the battery space. But the same sort of framework could be applied to things like EVs or robotics or all of these macro trends that we see in technology. And the basic concept is that a Gen 1, in the first generation of a technology, you're really basically starting from scratch, right? Think about Tesla starting with EVs. There were no real mass market EVs at the time. You're pulling people from adjacent industries to go apply to your challenge. This was certainly true in the battery space where people didn't know how to manufacture batteries in the beginning. So they came from materials or they came from semiconductors. And there's these three components. There's the talent side, there's the technology side, and then there's the infrastructure side that are what we focused on. In Gen 1, as I mentioned, you're bringing people from adjacent spaces to come work in the company, but none of us had done this before. The technology is being invented at the time, and there's really no infrastructure at all. It's a chicken and the egg type of a problem for the basic supply chain that ultimately needs to grow up around that particular industry. And there's no market yet. And so why, as a supplier, and whether it be equipment or materials, should you be forward investing into an application that's not yet proven? So this Gen 1 is very difficult, takes a long time, huge amount of capital because you're inventing everything from scratch. The winners that may emerge from there, they'll end up being the leaders in the industry, but super hard challenge. Then next comes generation 2 companies. And I would say like my previous company, NOVONIX, fits in that in that space. There's a handful of companies that are still working hard, and probably a few will make it out of Gen 2 in the battery space. At that point, now you at least have people who've worked in the industry before that you can hire. There's some sense of kind of the methodologies to whether it be doing manufacturing or whether it be doing data sciences. I remember meeting you, Tal, early on when you were building out kind of the data infrastructure around Voltaiq. And we looked at your products and we said, yeah, you're doing this exactly right. We really like your product, but we've just spent the last 5 years building out our own in-house data science program in order to basically have that same capability, because it didn't exist when we started. And so that's the second generation where you've gotten a little bit further along. There's some lessons learned. People have been in the industry, but still major challenges to moving fast. And the key is the next generation, at least from an investing point of view. Once you get to third generation companies, not only do you have talent that knows what they're doing, there's a whole foundation of technology that's been built out within the industry that you don't have to build yourself. And there's an infrastructure, not necessarily of people who know what they're doing, but of entire companies that have sprung up to solve the major problems that the industry faces. And so our thesis around Generation 3 companies, and Peak Energy is in the sweet spot of that, of course, is that you have all of the pieces in place around the industry, the infrastructure, the people, the processes, that then you can focus on the application and you can move much faster and achieve scale in a much more linear approach than you would have in Gen 1 or Gen 2. So that's the thesis. And we think in the battery space, we're at 3.0, and there's going to be some really quite interesting companies that come out of the hard work and the blood, sweat, and tears that we all put in Gen 1 and Gen 2. And it doesn't necessarily mean just American or Western companies. We're seeing a number of really interesting Gen 3 companies that are emerging in China, right? These are companies that are startups or popping out, and they're getting to scale much more quickly than they would have otherwise, because they're building on what CATL, BYD, these guys did early on.
As Cam brought up at the beginning, this is not just for lithium-ion technology. They're working on sodium-ion right now, and we have customers across the spectrum, a whole range of different battery chemistries, from lead acid to lithium sulfur to lithium ions. It definitely applies across all of the technologies here.
Right. And if you think about sodium ion, it's a similar chemistry to lithium ion, but it's a whole different flavor. But it's being built in this concept of 1.0, 2.0, 3.0. It's built on a platform of process technology, of equipment lines that were designed to build lithium ion. They can build sodium ion. People who've done this before, all the data infrastructure that goes behind it, and the factory infrastructure that goes behind it. So we expect to see, like, the introduction and then ultimately the maturing of sodium happen probably 10 times faster than what we saw with lithium ion and LFP.
Mm-hmm. Yeah, let's talk through one of the ways to compete is to learn faster. Some say that's the only sustainable competitive advantage. And digital technologies that allow you to learn that. Tesla built that in from day one. One of the companies who has gone through this transition of trying to build tools and now going down the path of bringing in solutions like Voltaiq. Chris, I'm just interested in your take on that transition and learning process of getting more competitive going forward.
Yeah, I think it builds on a lot of things that Cam brought up, because you need people and you need talent, right? There is no way you can innovate. There's no way you can scale. There's no way you can succeed without that. But I think one of our big challenges here in this industry, whether it's sodium or lithium, but in the battery sector, let's say in North America, is the scale ramp went too big too quickly in terms of our needs for talent, right? Mm-hmm. So when a lot of companies started raising huge capital over the last number of years, we went to some of these 1.0 companies, basically really only Tesla, right, in North America, and suddenly said we need somebody to run 50 battery projects across the country. It just didn't exist. So people were fresh graduates from PhDs, and they were accelerated to be people leading programs. And China's had the ability to build that up more over time. But you need to resource those people with the best tools. And that was really how we even started NOVONIX, right? When I was doing my PhD, we got very focused on long life batteries. So this is the late 2010, the late 2000s. And the question from the scientific lens and the research lens was, if we change the chemistry, we tweak the material, if we already have a 10-year battery, how long does it take us to figure out if it's better or worse, right? Because if it takes you 2 years to answer that question, how can you ever innovate at any reasonable speed? And we talked about it a little bit in the introduction, but this was the introduction of our ultra-high precision coulometry technique. So how could we get data in weeks that could help us make smart decisions, right? Empower our scientific resources to be moving quicker and to make sure that talent is being deployed. And then you have to say, how much can I learn from that data? And we went down the path of saying, okay, we have full battery pilot lines within our research and development teams and services groups, or build all sorts of formats of cells, thousands of test channels. We said we need to learn more. And just like Cam talked about, the first instinct is start small, start building your own tools. They become very specific for your needs. But we quickly learned, one of your questions at the beginning, how hard can it be? It's not always about how hard can it be, it's about core competencies, right? And you have to focus on the complex challenges that your business has and needs to make work. And unfortunately, there's so many supporting factors to that, but you can't be that for everyone. And I get asked that question a lot in the vein of the material side, because I spent 2 years at Tesla. We did a lot of work around graphite supply chain, and we said that it's going to be a massive problem. And I left Tesla and we set up our nanomaterials group to try to be one tiny fraction of the solution to that. And people always ask, why didn't Tesla just do it? Tesla's got plenty of their own problems, right? Plenty of their own challenges to focus their talent, their tools on. So this is taking a village to raise the child of this sector. We need so many participants across so many different areas to leverage data, to learn faster, and to be competitive.
It's a great point, Chris, particularly around the Tesla mindset of, obviously they have done a lot of stuff in-house, vertically integrated in ways that other companies have not. But you were there, you talked to people who were there. They didn't do that as a strategy. They did that out of necessity. Because they were a 1.0 company, these things did not exist. Panel-based infotainment in cars did not exist. The way that manufacturing processes were done and giant stamping machines did not exist. So why do they do it themselves? It's because it wasn't a thing in the world. Now there are very high quality solutions that that exist, whether it be in the materials and R&D space where you guys are, or in the data analytics space where Tal is. These are things that you can build a company on top of and just go so much faster than we did in the early days.
Tesla was in a unique place in time as this came up, and you look across people who've worked at Tesla, and where just about every engineer who's young, came out of Silicon Valley, came out of good schools, was hungry, and just about every employee knows how to write some code and put stuff together. And then you go to factories in the southern part of the US, and there's two people, you could put it on one hand, who knows how to actually write any code. And the key is having these solutions that allow you to bridge and allow that learning to happen, in a modern workforce that is not necessarily going to be in the Bay Area and have the talent pool that Tesla has. So one of the other questions here, China was the topic we brought up. You often hear it's us versus China. Is that the correct framing? Let me bring that to each of you. And Cam, do you want to go first?
Sure, yeah, happy to jump in on that. And my point of view and how we've built the strategy of peak energy is that it's not the correct framing. It's part of the framing. I think there's no industry or country where having one of your critical industries completely concentrated in one part of the world or one country is a healthy ecosystem. So we're in a very unhealthy spot, I would say, from a battery perspective, because so much of the critical supply chain goes through China. And so the way we think about it is really diversifying the supply chain, as opposed to it's a geopolitical competition between the United States and China. And the second point around that framing is that we also think, given the way the industry is today and given where the strength is, particularly in the supply chain, we think it's not a winning strategy to just build an American company, wave the flag, and say, we're going to do everything ourselves here in the US. We think that's not a competitive approach. And we think that a successful strategy in today's world means partnering with our friends in China, but also having a longer term vision of ultimately diversifying that supply chain and the manufacturing out of just one particular location in the world, which is not healthy for the industry. It's not good for our customers. Ultimately, it's probably not good for our partners in China who want to build their businesses in a worldwide way as well. So we think it's a much more nuanced question. You need to engage and you need to take advantage of the strengths of the ecosystem there, particularly in terms of cost and scale. But we think over the medium term, there are really interesting opportunities to work together with partners to essentially scale out that capacity beyond just one country. And that's what we're trying to do at Peak.
Chris, let me
Yeah.
pass it to you.
Yeah, I agree a lot with the way Cam looks at it. I think that people also need to take a step back and remember the timeline of kind of evolution of the sector. And that's why I think your intro 1.0 and 2.0 is so important because, again, in North America, we've had so many people come to the sector over the past, let's say, 4 or 5 years, right? But this is an industry that moved to China 20 years ago. But remember, lithium iron phosphate was invented here. NMC was invented here. Like we had a thriving graphite industry here, right? These technologies went to China, let's say at that point in time, because it was the path to bring $1,000 per kilowatt or watt hour to 100, right? Now what we have to do is find that healthy balance, Cameron's point, because we're in an unhealthy balance now where as a world, not just as North America, we're too reliant on China for our battery industry. But that doesn't mean that we need to prevent them from supporting global growth. Of course, the nuanced balance to that is the political landscape and understanding that we have friends, we have colleagues in China, we have things that we leverage from the experience they have because they're simply the truth. They didn't just copy technology and make it cheap. They're now leaders, right? They've innovated past many of the companies in North America, right? But there are anti-competitive behaviors from China and the Chinese government. And this is where politics comes in. And of course, we've seen that play a huge role in infrastructure law, IRA, the tariffs that have come back and been instated. And so we need to ensure that we can work with and participate alongside China, but also in a fair global playing field, right? That way we can build this healthy diversification. And if we think about IRA specifically, there are certain exclusions for Chinese goods or foreign goods, and then there's free trade agreement countries, and there's local production. Every company is going to take a different strategy in how they want to break down their supply chain from FEOC, from free trade, and also what percentage they want onshore. And there are cost benefit analysis and everything to what's a very complex supply chain. And so I think we need to not just think us versus them. We need to think where do we compete and where do we collaborate globally with all other countries.
Agreed. And one of the questions coming in here is about legislation as well. And I think that's one of the things, if you look at the last 20 years, China had a very clear strategic plan when it came to the electrification and batteries more generally. But one of the key things, I think, from a legislation perspective that makes it easy to make these investments, when you put a mine in the ground, when you start building your anode factory, when you start making battery cells or packs, it is the long-term incentives that really and clarity around those that makes it easy to bring the financing in and have that long-term vision and see it through within the sector. And so I think that is one of the big key areas that our governments could really support this industry going forward, is really provide some clarity long-term around these incentives, and whether it's sticks or carrots, just really have some clarity there. One of the questions that continuously comes up, I'm sure each of us here, is it time to just throw in the towel? Do we need a step change in technology? Do we need something like solid state? Can we be competitive with more traditional technologies, or do we need these next gen technologies to really emerge to give us a path forward? Just interested in your take on the topic.
Our view on this is that it's extremely difficult to really start with a blank sheet of paper around the manufacturing infrastructure and supply chain and kind of leapfrog everything that's been put into the ground today. around the manufacturing infrastructure for batteries. So I think that is a very difficult challenge for the solid state companies that are trying to make that work. On the other hand, I also think that it's not necessarily a winning strategy for the U.S. government, the U.S. taxpayer to just subsidize existing capability that already exists around the world, whether it be LFP or other kind of established technology. So we do believe that part of what makes for an interesting company and a way forward for the industry is a shift in technology, and that's the reason why we've chosen to go after sodium ion, which is built on that 3.0 platform of tools and manufacturing and supply chain that already exists in the world. But it is a different technology. It has pros and cons in the marketplace, and we think it's advantaged, particularly in stationary storage today. And it allows enough space in the marketplace with the support of the policy to go build a major company in North America. There's no CATL of the United States today. How could that be, that in such an important industry as batteries, that we don't have a major player domestically grown? So we think that's an opportunity. Partly it's technical because of the shift to sodium, particularly in ESS as a first market, but it's also part and parcel of the policy discussion that we just had. We think the timing's right to go build a major company now in the U.S.
Yeah, I think the government has to balance that. They do need to subsidize today's technologies to be able to ensure we do have some growth of existing technology, because even existing technology, look at NMC, LFP, graphite silicon type of cells, these are not displaced by new technology, whether they're sodium, whether they're solid state. We have so many diverse needs for energy storage. And I think this is something that was lost for a long time, was that people talked about batteries. Then they talked about EV and ESS, right, as just two classes. And then you realize EV has 10 classes, ESS has 10 classes, right? So there is not, people want to know what's the battery technology. There will never be an answer to that question. The same reason that we still use nickel metal hydride and other batteries and other applications, right? There are pros and cons to all of these things. So I think we do need to build today's technology, but we also have to look at the right technologies to pour innovation into. And I think it's exactly what you said, learning from that 1.0 time and moving into the right phase into 2 and 3. Because I also think a lot of people, they don't appreciate the history in this sector, where you look at a lot of solid state or silicon-based companies that, let's say, got a lot of recognition, raised significant money over the last few years. Most of these companies started in 2010, plus or minus 2 years. So they're 10-year overnight successes, so to speak, right? And they probably had 5-year commercialization plans in 2010, and they had 5-year commercialization plans when they IPO'd or de-SPAC'd in 2021. And some of them are delivering and some of them aren't. And that's the nature of the beast. These are hard challenges. But I think for a long time, we've said what we'll do is we'll innovate past China. They're going to just try to go cheap, and we'll innovate past China. And I started spending a lot of time in China, mid-2010s, early 2010s. And I'd come back to industry conferences here in North America where everyone would talk about how amazing we were and how advanced we were. And I wondered how many people had been to China, because they were marching past us and we were not acknowledging it at all. So we have to find that healthy balance. And I think sodium's a great example of something where there's established infrastructure, there's established technology. There's also still companies that have been doing this in the US for 10 plus years, 10, 15 years to gain some commercial traction. Now's the time to try to catch that inflection point and really deploy some winning technologies in a few classes.
Yep. Yeah, it's a great point. It is amazing the gap in understanding of the world that exists between folks on both sides of the Pacific who are traveling back and forth and really seeing what's happening in both places with their own eyes, versus it's pretty easy to give a talk at a scientific conference
and talk about how exciting the world can be. But
you're absolutely right.
A lot of work to get done to move from A to B, right?
Yeah, I think a couple lessons here is definitely try to utilize what's coming out of China and Asia as well. It's not, we try to go at them directly. It is a partnership and collaboration, and there's opportunities to learn and leverage technology, people, expertise that is out there. And then there is no one size fits all chemistry in the battery space. And so it's think wisely when you choose the niches you go after and expand from there is all I'd say. Is if you want to go directly at LFP today and the price points, it's going to be very difficult. And so really choose your entry points and where you're focusing your efforts there for your company. And so, yeah, to close things out, there's going to be a range of other questions, and we're happy to follow up live if you email us or continue the discussion there as well. But there's a number of questions about education. What are you excited about? How to get started? What is each of your advice to newbies in the space or people who are trying to transition into the battery space? How do you guide them? How should they learn? What areas should they focus on the supply chain? What kinds of technologies? I'm just interested to hear each of your advice to younger people in the field.
Maybe I'll go first because I'm going to guess I'm going to pick more upstream than you can. So I'm a big materials process guy. I think we have so much opportunity to innovate in process technology. So whether you can take any number of kind of disciplines and career paths to do this, whether you're in chemical engineering, physics, chemistry, you name it. But I think it's about being curious about not being stuck in the norms, even whether they're today's materials or tomorrow materials. We've now built enough knowledge about how we make certain things that I think sometimes we're worried about taking a turn away from the norm, and we're stuck optimizing when we could be innovating. So I think there's so much opportunity to be curious on how we can have more sustainable, lower cost process technologies that maybe aren't decided based on limitations that existed 10, 20 years ago when these initial technologies grew up, whether that's things like DLE or others. You can go down the list. But I think there's a lot of opportunity to be curious and innovative in process technology, not just optimizing.
Maybe hearkening back to the Battery 3.0 point of view, the beauty of where we are now as an industry is the energy storage space writ large. Clearly, if it isn't already, will be one of the largest industries in the world, growing like crazy. And 15 years ago, certainly outside of Asia, if you wanted to work in the battery space, you were basically working at an R&D company. If you wanted to work in batteries, you needed deep technical R&D skills. And you probably came out of school and, we're working on a PhD thesis or something in that space. That is not the case today. Today, this is a maturing industry, adding thousands, tens of thousands of jobs across the board, from the technical skill sets, hardcore engineering, software, but also the business functions, supply chain, the sales and marketing side. And so I don't think you don't need to choose a specific technical field in order to work in a space where the mission is really important, right? Green energy, whether it be on the transportation side in EVs or what we're doing in grid scale storage, that can be a motivating factor for anybody who's smart and motivated and has broad business skills that are needed across any company. So it's like where the semiconductor space was maybe as it was maturing in the 80s. And it created a massive industry with need for talent across the skill set space. And I think we're basically at that point now in Battery 3.0.
100%. And I think it's as a call here, just go and make the transition if you're looking for something new. So if you wake up in the morning and you're not excited what you're doing, it's time to go take that next journey and just keep your mind open and learn. I think the one thing in the battery space is it combines so many different domains on the process side, from the materials through the chemistry, the physics, the mechanical engineering to put this all together. And so just don't feel trapped by whatever education you had, and just be open to learning and starting to put together the requisite skills and understanding to piece this all together, because we're figuring it out now as we're going. And with that, I'd like to thank our speakers. Chris and Cam, thank you so much. I thought it was a great discussion. Looking forward to doing more of these in the future.
Absolutely.
Thanks for the opportunity. Yeah, I really appreciate it, Paul. Thanks.